and talk about what that means and how to find it. So far we have been finding the derivatives, differentiating problems that have been in explicit form. So when it's in explicit form, it means the problem is solved for y. See, it says the y variable is explicitly written as a function of x. So it just means that we've been working on problems that have been solved for y so far, like y equals 3x squared minus 5. You know, we've been doing the derivatives of those. So we could easily find the derivative of that function. When it's already solved for y, it's easy to do. So to find the derivative of y, it's y prime. Another way to write derivative of y, and I've written it a few times, you're finding the derivative of y with respect to x. That means the same as like y prime, dy dx, same as y prime. It's just faster, we've been writing y prime a lot. So how do you find the derivative of y, the dy dx or y prime? How do you find it? What would it be for this one? 6x. That's it, right? Because the derivative of negative 5 is 0. Okay, so that's easy. But some functions, however, it says, it's difficult to express the function, express y, like make it, it's harder to make this one like y equals. In some functions, it's difficult to express y as a function of x. So the following function here is written in implicit form. It has x's and y's, and you could do it, but it would probably take you a little bit to solve that for y. It's kind of messy. So to find the derivative of implicit functions, we use what's called implicit differentiation. The problem's like mixed up. It has x's and y's on this side of the equation. It has x's and y's together. It would be kind of time consuming to solve that for y. So to find the derivative, or dy dx, it says you must realize that the differentiation is taking place with respect to x. And you can differentiate terms that just have x in it, just x alone as usual. But if we're going to find the derivative of things that have a y, you have to apply the chain rule, because you're assuming that y is defined implicitly as a function of x. So it's basically every time you see a y in the problem, if we're going to be trying to find, whenever you see a y, and whenever you have to find the derivative of y, they write dy dx. You'll see how it works, so we'll kind of show you. So they give you, I have a few examples here. We're always finding the derivative with respect to x. So this is a normal one. What's the derivative with respect to x of x to the third power? Yeah, that'd be 3x squared. They kind of say if you look at, I have a PowerPoint posted of this stuff, it says the variables agree here. Like the x, we're finding the derivative with respect to x. They say, like if this is x and you're finding the derivative with respect to x, like the notes in the PowerPoint say, well, the variables agree, so you just use your normal power rule. Bring the 3 in front, subtract 1 from the power, you're done. We found the derivative with respect to x. But see, now we're going to do another one, and it says, find the derivative with respect to x of y to the third. So they tell you, just to kind of look, see, we're finding the whenever you find the derivative, we're usually finding the derivative with respect to x. So the variables disagree, so they say that's why when you have terms involving y, you must apply the chain rule. So you kind of do it like the last one. Like we look at it's y to the third. How do you think you do the derivative of y to the third?
3y squared.
So you put 3y squared. But see, then we're trying to find the derivative with respect to x. So then you have to apply the chain rule. So then they write times the derivative of y with respect to x times dy dx. Like, do we know what y represented? So you're using the chain rule. Then you just write times the derivative of y with respect to x. So every time you're doing derivative of y things, you're going to be writing like times dy dx at the end. Or y prime. We can start using y primes too. Like dy dx is the same as y prime. So we could have also written it as 3y squared times the derivative of y times y prime. That's the same thing. You could write it this way or this way. These are the same. You know, those two things are the same. You could write it this way, 3y squared times the derivative of y with respect to x, or you could write it 3y squared times y prime. That's the same. Okay, let's try another one. This one said, this is, see in front, this means take the derivative. We're trying to find the derivative with respect to x. That's what, when they write that little d over dx, it means we're trying to find the derivative. So let's try to find the derivative of this one. Okay, so what's the derivative of x? 1. What's the derivative of 3y? 3 times, yep, dy over dx. Or, could you write it a different way? Instead of writing dy dx, what's another thing you could do? You could write y prime, and that's fine also. Yep, you could be 1 plus 3 times y prime. I just noticed the book does it this way. The book does it dy dx. I've seen people write y prime too, so. That's the same answer. Those are the same answer. Okay, now this one. Ooh, this one looks tricky. It has an, we're going to try to find the derivative of x times y squared. Xy squared. How do you think we find the derivative of that? Yeah, you still use your product rule. Use product rule. Okay, so it's like a multiplication here, so we're going to use our product rule. So product rule first times the derivative of the second plus the second times the derivative of the first. So first we have x. What's the derivative of the second part? 2y times dy over dx. See? First times the derivative of the second. It's tough. Plus the second thing in the problem, y squared times what's the derivative of the first thing, which is x, which is 1. Yeah, derivative of x is 1. Okay, so this, I mean, I would kind of clean it up a little. You could write it as 2xy. It has an x and a y. You could write 2xy dy dx plus y squared. Okay, so now I think you're getting the idea of it. Every time you find the derivative of a y, you have to write dy dx. You have to write that, add that chain rule on. So there's some guidelines for differentiation because we still didn't, that was just kind of an intro to it. We still haven't done like a whole problem. Now we're going to get to doing a whole problem with it. But these guidelines say differentiate both sides of the equation with respect to x. Okay, then we're going to start collecting all the terms that have the dy dx in them on the left side of the equation and move all the other terms to the right side of the equation. Then we're going to factor out the dy dx out of the left side and then finally solve for dy dx. So it's after we do the steps, then we kind of organize our work and finally solve for dy dx. So let's try one. So we're going to try a whole equation now of what this is kind of like what your assignment will be like. Differentiate the following equation and then find the slope at the points 2, 0 and 1, 1. Find the slope at a few different points and see how it comes out. All right, so let's try this one. Differentiate the following equation. So it has finding the derivative of this. So what do we think? Because see, it's like hard to take, it would be really time consuming to get this equation solved for y and make it like y equals. that, it's obviously easier to take a derivative when it's just y equals. So it's just our way to work around that and organize it and get it figured out. So what's the derivative of y to the third?
3y squared.
Yep, 3y squared. And every time we take like a derivative of a y, then you write dy, do the chain rule, times dy dx. Okay, what's the derivative of y squared? 2y times what? dy dx, yep. It's kind of weird. Takes a little getting used to. Okay, now we're going to do the derivative of the next part. Derivative of minus 5y. What's the derivative of that? Yeah, it'd be negative 5, be minus 5. And then what?
Times dy.
Yeah, times dy dx. Every time you find the derivative with a y part, you're going to have to write dy dx. Let me zoom it out a little. Okay, now we have just a derivative of this next term, minus x squared. What would that be? Minus 2x. So that one's good. That one you only write this dy dx when you're dealing with y terms. Does that make sense? Okay, then equals, then what's the derivative of negative 4?
0.
Yep, that's a constant derivative. That's 0. Okay, so we differentiated both sides of the equation with respect to x. Now it says to collect all your terms that involve dy dx. Okay, so this has a dy dx in it, so does this, so does this. So the other, it says move all other terms to the right side of the equation. So I can add 2x and move that over here. See, I'm going to add the 2x and bring that over here. Now, all the things that are left over here have a dy dx in them, so then it's going to tell you to factor out the dy dx out of the left side. Everything has dy dx in it, so you can factor it out. So it's going to be dy dx, parentheses. So then it'd be 3y squared plus 2y minus 5. How's that so far? So we added the 2x over, took out the dy dx out of everything. Look good so far? And then now we're on the last step. Solve the equation for dy dx. Like when I'm done, I want the derivative of y with respect to x to be the only thing left. So how do you think I could do that? Now what? Yeah, divide by this parenthesis group, this 3y squared plus 2y minus 5. Divide both sides by 3y squared plus 2y minus 5. Okay, so if you divide, that'll cancel over here, so I have dy dx. That's the derivative of y. See, now we found the derivative of y with respect to x equals 2x over 3y squared plus 2y minus 5. So that's our derivative with respect to y. See, after you organize it, it's like the same as if it would have been y equals to start with, and that's our derivative of y. That's the same as y prime. This dy dx is the same as y prime. Y prime equals this. The derivative equals this. Okay, so then they might ask you on your assignment to find the slope at different points. So we got this equation here. Found the derivative, we differentiated it. Now, how do you think we would find the slope at like a point like 2, 0? What would you think we would do? Yeah, this 2, that's x. 0 is y. You could plug those in down here for the x's and the y's. Does that make sense? So we could plug it in. It'd be like, at the top it'd be 2 times 2, x is 2. And at the bottom it'd be 3 times y. Well, y is 0, so 0 squared. And 2 times 0 and minus 5. what would you get for the slope at the point 2 comma 0?
-4/5.
Yeah, -4/5. Good job. That'd be your slope at the point. I'll put M for slope. Yeah, good job. I'll zoom that out a little. And then what if they wanted you to find the slope at a different point? What about the point 1 comma 1? Could you do it again with a different point? So it'd be like at the top it'd be 2 times 1. And the bottom would be 3 times 1 squared plus 2 times 1 minus 5. So I'm getting 2 at the top. What do you get at the bottom? You get 0. So what's the slope? Undefined slope. When you have slope, then you get a 0 at the bottom. They write undefined for the slope. I can show you the graph. They did that one on the PowerPoint, and they have a nice picture of it too. I'll go to the PC. So this, I'll go to the PowerPoint. Yeah, this one's undefined. Okay, let's go to the camera. So this was in the PowerPoint, this question. And that equation you worked on, and we did the implicit differentiation. That was the equation. That's what it looks like if you graph it. And then finding slope at different points, like we tried the point 2, 0. Here's the point 2, 0 on that graph. We got a slope of -4/5 there. Like if we drew a tangent line there, yeah, that makes sense. It would be going like downhill. And at the point 1, 1, why is the slope undefined there? Well, look at the point 1, 1. If you made a tangent line right there, it'd be a tangent, the undefined slope. Tangent line would hit like right there, be up and down, it'd be undefined. They had you find slope at different, they found the slope at different places. So it'd be different points on the curve. The slope at x equals 0 is 0. It'd be a flat line there. So remember, slope is like, you could draw those tangent lines to those different places on the curve. So yeah, having that visual, that kind of helps. Okay, so now we're going to go to the back of our notes. We're almost done here. So it's just like recalling that you can't find the derivative. You can't differentiate at points where there are vertical tangents, at points where the function is not continuous, or at points where there's a sharp point or a cusp. Like a absolute value function at a sharp point at the bottom, you couldn't find the derivative right at that point. It's like derivative does not exist when you have a sharp point. Okay, so now we got another one here. One more to look at. We have another function here. And yeah, it would be really difficult to go through this and just solve it for y and get all the y's together and solve it for y equals. So since it has x's and y's all mixed up in the equation, you need to use the implicit differentiation to try to figure this one out also. All right, so we need to try to find the derivative of this function. Yeah, so it's kind of messy, isn't it? All right, so this one's kind of a mess, really, because there's a lot going on here. 3 times x squared plus y squared squared, and then you have 100xy. Yeah, so this one's kind of tricky, isn't it? All right, so if it helps you guys, if it helps you, sometimes it helps people to see, like this is like an inside part squared. And I'm just underlining that you see it's a group of things here squared. Ooh, how are we going to find the derivative here? Yeah, there's going to be a lot of steps on this one. So you have a power out here. If you're going to find the derivative, I would do your power rule first. Bring the 2, like 3 times 2. What would that be? 6 times this x squared plus y squared. And then the power would go down by 1. You know, you do that power rule. 3 times 2 is 6, and then you subtract 1 from the power, so it's this to the first power then, right? So it'd be 6 times this to the first. And then you have to times by the derivative of this inside stuff. Yeah, it's a chain rule. Okay, so what's the derivative of x squared? 2x. You can put parentheses if we want. Okay, what's the derivative of y squared? 2y. Yeah, times y prime or dy dx. Or dy dx. Okay. So I think we got that part because, yeah, it has like the derivative of the inside. This is like the inside stuff. You could have said that's u, and then, yeah, this is the derivative of the u, the inside stuff. Okay. Over here we have 100 and then x and y. 100xy, like 100x times y. Okay, this side's a product. So I would do the first times the derivative of the second plus the second times the derivative of the first. So first is 100. I would say first you have this 100x. You know, just put that, and then the second thing is the y. So first is 100x. What's the derivative of y? Yeah, 1 dy dx. Or derivative of y is y prime. It's y, you can think of it as y prime if you like. That's fine. You can put y prime. Then at the end, you know, then you just have to gather the y prime stuff together. It's the same thing. Okay, first times the derivative of second plus the second thing was y times the derivative of the 100x. What's the derivative of 100x? 100. Yep. Oh, let me move it out. Yep. There we go. Yeah, it's a lot to collect and keep together and keep it all organized. Seeing how I can collect. Yeah, we have to kind of like collect things together and get it organized now. All right, so what do we want to do here? Let's see how they kind of collected their terms. Yeah, it's just like it is kind of messy, and you're going to have to get it kind of organized. So you have 6. Do you want to distribute this 6? So we have 6x squared plus 6y squared. And then, so we have this times 2x plus 2y dy dx. And then over here we have 100x dy dx plus 100y. Yeah, these are a bit tough, a bit time consuming. There's a lot going on here.
I have a question.
Mm-hmm.
Why did we put the dy dx with the 100x and not the 100y?
Okay, so on this one we had to do first, we had to do the product rule, so we had to do 100x, and then it was times the derivative of y.
Yeah, that makes sense. Thank you.
But the second part didn't have it because it was just the y times the derivative of the x part, and the derivative of the x part was just 100. Yeah, it's tough. Okay, so we got to get this a little more organized too. What else? What else should I do? Oh, it's a lot, isn't it? Want to distribute all this? So that'd be 12x to the third plus 12x squared y dy dx plus 12xy squared plus 12y to the third dy dx equals 100x dy dx plus 100y. Yeah, it's messy. It's a lot. So we got it all kind of figured out though now. Then they tell you to, if you read the steps, then it said collect all the dy dx terms on the left and move all the plane terms that don't have a dyx in it to the right. So we want to move things around, collect things. So we have 12. This, you know, see, I'll circle them. So it's basically this one, these things that have dy dx in them, we want to move them to the left. So we have 12x squared y dy dx. We have 12y to the third dy dx. And then how would we move this over? Yeah, subtract this 100x dy dx. Yeah, so it's a lot of organizing. So those three things in red we got to one side, and then I can move the other items to the other side. So we have this 100y already over here, which is fine. We have 100y, and then maybe like minus 12x to the third and minus 12xy squared. Yeah, it's messy. Then they say to factor out the dy dx. So now I have 12x squared y plus 12y to the third minus 100x equals 100y minus 12x to the third minus 12xy squared. See, you get it. It just takes a while to get it all. And then divide by this. So you finally get dy dx by itself. You have to divide by that parenthesis. Yep, it's a big mess. I know. Takes a while to get it all organized. Okay, then they say, well, I mean, you could do some factoring probably there and get out, like, I see they're all even numbers. You could do a little factoring, or you could just leave it. It doesn't matter. Let's just leave it. It's a mess. So they are kind of messy problems. And then it said, write the equation of the tangent line at the point 3, 1. So if this is the dy dx, this is the derivative of y with respect to x. Okay, we got it. It's here. Now write the equation of the tangent line at the point 3, 1. So what should we do with these 3 and this 1? Yeah, plug them in. Put in 3 for the x's that you see in the problem, put a 1 for the y's, and figure out, that would give you what? What would that give you if you plug these in? What are you finding? What's dy dx mean?
The slope.
Yeah, that will give you the slope. So if you plug these in, then you'll find the slope. So that's, you know, we get there, but just, yeah, you can see they're quite time consuming. So we have 100 times 1 minus 12 times 3 to the third minus 12 times 3 times 1 squared, and then 12 times 3 squared times 1 plus 12 times 1 to the third minus 100 times 3. So let's figure that out. I did the top part, if I did it correctly. I got negative 260. See what I get for the bottom. 3 squared, and then 12 Then we can reduce. If you reduce this down, negative divided by negative is a positive. Reduces down to 13 over 9. That's your slope. All right, so, and it's on the PowerPoint too. That's what the PowerPoint has. They didn't do it quite exactly the same because I was looking at it and like they did some factoring up in here, but it doesn't matter. You don't have to factor things all the time. We plugged it in. We got the same answer as they did. So 13 over 9. So what about writing the equation? Let's see if we did everything they wanted. Write the equation of the tangent line at the point 3, 1. Well, we got the point 3, 1. We plugged it in. We got our slope. How would you write the equation of the tangent line?
Y minus y sub 1.
Yep, do your point slope formula, and then we got it. Y minus 1 equals, then we got our slope 13 over 9 times x minus 3. That's it. You can leave it like that too, because it doesn't say like in slope-intercept form or anything. If you wanted to put in slope-intercept form, you could. You could distribute. Yeah, this is your equation. You could distribute that and solve for y, and then you finally have the equation. Wow, that was quite a bit, wasn't it? All right, so let me show you too on the PC that same problem. I just like to show you the graph of it too. Like they graphed it and everything. Cool. So the problem we started with, let me flip it back over to the PC. It's on the PowerPoint, like I was saying. See, that was the equation we started with. We did all that work and we got it. And they graphed that too so you can see what it looks like. It's kind of cool. It's kind of a cool shape. They graphed it here. That equation they originally gave you on this one, here's the graph of it, of that 3x squared plus y squared squared equals 100xy. It's a shape called a lemniscate, kind of a infinity sign, you know. Looks like an infinity symbol, sideways 8. And we found the slope at the point 3, 1. See that blue line they drew right there? We found the equation of that line. You just found the equation of that line. We went off the point 3, 1. The slope there is 13/9, and we found the equation of that line. We just wrote down the equation and the point slope of that line. So yeah, it's quite a bit. They do give you some different shapes on this lesson, like that one's a lemniscate. They're like famous curves, they call them.